Good evening and welcome to this special report about the future of fuel use in China. Tonight, we will demonstrate how a recent innovation in cellulosic bioethanol technology will revolutionise transport in China by cutting petrol use and reducing the cost of passenger travel.
China is the second largest importer of crude oil in the world. With its population set to increase to 1.5 billion by 2025 and the price of oil rising, China is going to have to find a low-cost solution.
China is the largest producer of rice in the world. It accounts for about a third of total world production. About 20% of the total paddy weight is made up of rice husks. These are the hard outer shell of the rice grain, and at the moment are either burnt or sent to landfill and have no monetary value. We propose to use these rice husks to extract cellulose and turn into bioethanol.
Rice is, I think, one of a number of different feedstocks that will play a very important role as feedstocks for transport fuel production, particularly in places like China.
We expect the environmentally sensitive nature of our idea to appeal to the Chinese government. China is currently a member of the UN International Biofuels Forum and is already the third largest producer of biofuels in the world.
China has set targets to reduce its fossil fuel use. By using biofuels, they can achieve these targets in a short time period, as well as lowering their overall CO2 emissions. This will also help China to reduce its dependence on US and Arab oil supplies.
The process of making bioethanol consists of three key steps. Firstly, cellulose is extracted from the rice husks in the pre-treatment phase. This cellulose is then hydrolyzed to basic sugars, which are fermented to form bioethanol. Pre-treatment is the most challenging stage of the process. This is made difficult by the strength and complexity of the rice husk, meaning that high temperatures and harsh acidic conditions are required. A number of methods have been explored to try and make this process more energy efficient. For our method, we propose to use a combination of mechanical and thermochemical processes, combined with an enzyme complex specific to the rice husk, which should provide a lower temperature, reducing the energy demand.
In order to implement our idea, we propose using a hub and spoke model, whereby we will place small pre-treatment plants near rice processing facilities and have a large centralised fermentation plant. This will reduce transport costs and increase efficiency.
The fermenter will be thousands of times this size.
Based on the efficiency of bioethanol extraction and the annual yield of rice husks in China, we propose a 10% blend of ethanol in petrol. This reflects successful policy that has been demonstrated in Brazil. At this 10% level, no modification is required to car engines, meaning that cost saving can be felt with immediate effect.
Using the costs of current production of cellulosic ethanol from corn stover and assuming that rice husks represent a significantly cheaper feedstock, we have calculated a production cost for bioethanol from rice husks of 60 cents per litre. Taking account of the lower energy density of ethanol compared to petrol, a 10% blend of rice husk biofuel gives a saving of 2.88% compared with pure petrol for every kilometre travelled.
This report has shown that China has a great need for a low-cost and sustainable fuel. By making use of the abundant and low-cost feedstock and achievable scientific developments, we believe that cellulosic bioethanol from rice husks offers a realistic way for China to reduce the cost of travel. That's all from us here at Green Ideas. Good night.